Hello, friends. So today we are going to have interview questions on the microservices, which is being prepared by me. So let's start. What are the recent questions on the microservices can be asked? So name three commonly used tools for microservices. First one is Docker, a containerization platform that allows microservices to be packaged into lightweight, portable containers that can run consistently across different environments. Second one is Kubernetes, an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications, including microservices. Third one is API Gateway, a layer that sits between client and microservices, routing requests and handling authentication and authorization. It can also perform additional functions such as traffic management, monitoring, and rate limiting. What is monolithic architecture? Monolithic architecture is a traditional software architecture in which an entire application is built as a single self-contained unit. In monolithic architecture, the different components of applications are tightly coupled and run as a single process on a single server. This means that any changes or upgrades to one part of the application requires building and redeploying the entire applications. Second, typically a monolithic application consists of a client-side user interfaces, a server-side application layer, and a database. All of these components are combined into a single executable file or a set of files that are deployed to a server. Third is while monolithic architecture are simple to deploy and develop and deploy, they can become increasingly complex and difficult to maintain as applications grow larger and more complex. Scaling a monolithic application can also be challenging as the entire application must be scaled up or down as a single unit. This can lead to issue with performance, availability, and reliability. Third is, what are the advantages of microservices? There are several advantages of using microservices architecture, including first one is scalability. Microservices architecture allows for an easy scalable of individual service, which can help to optimize resource utilization and reduce cost. Each service can be scaled independently based on its specific requirements without affecting the rest of the system. Flexibility. With microservices, different services can be developed, tested, and deployed independently, which allows for greater flexibility and agility in development. It also allows for easy incorporation of new microservices and tools into system. Third one is resilience. Microservices architecture enables building applications that are more reliable and fault tolerant. If one service fails, it wouldn't necessarily affect the entire system, and the other services can contain to function normally. Fourth, ease of maintenance. Since microservices are small and focused, they are easily maintained and update than large monolithic applications. Each services can be updated or replaced without affecting the other services or the overall system. Fifth one is improved team productivity. Microservices allow team to work independently on a different services, which leads to increased productivity and faster development cycle. This also allows better collaboration and innovation within the team, better agility with business needs. Microservices architecture is typically organized around business capabilities, which makes it easier to uh, align software development with business needs and priorities. This can result in faster time to market and better customer satisfaction. What is Spring Cloud? Spring Cloud is an open source framework that provides developers with a set of tools and libraries for building and deploying cloud native application. It is built on top of the popular Spring framework and provide additional features and capabilities that are specific to the cloud-based application. Spring Cloud provides a range of tools and frameworks that help developers to build microservices based application, including service discovery. Spring Cloud provides service discovery framework that allows microservices to locate and communicate with other services in the system. Second is load balancing. Spring Cloud provides a load balancing framework that allows microservices to distribute incoming requests across multiple instances of service. Circuit breaker. Spring Cloud provides a circuit breaker framework that helps to prevent system failures by detecting and isolating failing service. Configuration management. Spring Cloud provides a configuration management framework that allows developers to manage application configuration across multiple environments. API Gateway. Spring Cloud provides an API Gateway framework that allows developers to create single entry point for all external requirements to the system. Overall, Spring Cloud provides a comprehensive set of tools and libraries that help developers to build scalable, resilient, and a cloud-native application using microservices architecture. Discuss use of reports and dashboard in the environment of microservices. My first point is reports and dashboards are useful tool for monitoring and managing microservices based application. They provide visibility into the performance and health of the system and allows developers to quickly identify and resolve issues. Second, reports can be used to generate detailed insight into the system performance, including metrics such as response time, error rates, and the resource utilization. Reports can be generated at regular interval on demand and can be customized to provide different levels of details depending on the user's need. Reports can also be used to identify trends and patterns in the system performance, which can help to guide optimization effort. Dashboard provides a real-time, at a glance view of the system performance. They can be used to monitor key metrics and KPIs and can be customized to provide different views for different user roles. Dashboard can also be used to trigger alerts or modification when certain thresholds are exceeded, allowing developers to quickly respond to issues. And our the fourth point is in the context of microservices, report and dashboard are particularly useful for monitoring the performance and health of the individual services as well as the overall system. They can also help identify and troubleshooting issues related to service dependencies, load balancing, and other aspects of the system architecture. Our last point is overall, report and dashboard are essential tools for managing microservices based application providing developers with the insight they need to optimize performance, ensure availability, and deliver a high quality user experience. What are the main differences between the microservices and monolithic architecture? On the architecture point of view, in monolithic architecture, the application is built as a single self-contained unit with all of the components tightly coupled and running as a single process on a single server. In microservices architecture, the application is component composed of multiple independent services, each running as a separate process and communicate with each other via APIs. Scalability. Monolithic applications are typically more difficult to scale as the entire application must be scaled up or down as a single unit. It, it const- in contract in contrast, microservices architecture allows for easier scaling of individual services, which can help to optimize resource utilization and reduce cost. Flexibility. Microservices architecture provides greater flexibility and agility in development, as different services can be developed, tested, and deployed independently. This allows for faster development cycle, easier incorporation of new technologies, and more efficient collaboration between teams. Our fourth point is resilience. Microservices architecture is typically more resilient and fault tolerant than monolithic architecture, as each service can be designed to handle failure independently without affecting the rest of the system. Maintenance. Monolithic architectures are typically more difficult to maintain and upgrade than microservices, as any changes or update to one part of the application requires rebuilding and deploying the entire application. In contrast, microservices can be updated and replaced independently without affecting the rest of the system. Business alignment. Microservices architecture is typically organized around business capabilities, which make it easier to align software development with business needs and priorities. This can result faster time to market and better customer satisfaction. Overall, microservices architecture provides greater flexibility, scalability, resilience, and business alignment than monolithic architecture, but it also requires greater upfront planning and architectural design. What are the challenges faced while using microservices? While microservice architecture offers many advantages and it also presents several challenges, some of the key challenges associated with microservices include: first one is complexity. Microservices architecture can be more complex than monolithic architecture, as it involves managing multiple independent services that communicate with each other via APIs. The complexity of can make it more difficult to design, develop, deploy, and maintain microservices based application. Second is distributed system management. Microservices architecture involves managing a distributed system, which can present challenges related to service discovery, load balancing, security, and fault tolerance. Testing. Microservices based application requires comprehensive testing, as each service must be tested individually as well as in combination with each other service. This can make testing more complex and time consuming. Fourth one is integration. Integration multiple services can be challenging, as it involves ensures that each service can be communicated effectively with other services and that the system as a whole functions correctly. Fifth one is versioning. With microservices architecture, different services may be updated or deployed independently, which can present challenges related to versioning and compatibility. DevOps adoption. Adoption DevOps practices such as condition integration and continuous development of CI/CD is a critical for managing microservices architecture efficiently. But this can be challenging for organizations that do not have a culture of DevOps. Overall, while microservices architecture offers many advantages, it requires careful planning management to address the challenges associated with managing a distributed system compressed of multiple independent services. In which case microservices architecture best suited? Microservices architecture is well suited for complex, large-scale applications that have high traffic, higher availability requirements, and need for frequent updates and changes. Here are some of the cases where microservices architecture is often the best choice. Large-scale application microservices architecture is ideal for applications that are large and complex with many different components uh, and subsystem. It allows these components to be developed, tested, and deployed independently, which can help to speed up development and development time. High traffic applications that have high traffic and requires a high availability can benefit for microservice architecture as it follows for scaling of individual services to meet demand without having to scale the entire application. Decentralized team. Microservices architecture is well suited for organization with decentralized team as each team can develop, test and deploy their own services independently. Fourth one is rapid development and deployment. Microservices architecture allows for rapid development and development as each services can be developed and tested independently and change can be rolled out more quickly and easily. Fifth one is heterogeneous environment application that needs to run on different platform technologies or devices can benefit from microservices architecture as each service can be developed using the best tool for the job. Continuous delivery is our sixth point. Microservices architecture is a good fit for organization that practices continuous delivery as it allows frequent updates and changes to be rolled out without uh, disrupting the entire system. Overall, microservice architecture is the best suited for complex, large-scale application that requires high availability, scalability, and frequent updates and changes, and that operation in a decentralized, heterogeneous environment. What are the characteristics of microservices? The following are the characteristics of microservices architecture. First one is modular. Microservices architecture is based on modular design where each service is deployed, developed, deployed, and managed independently. This allows for greater flexibility, scalability, and resilience in the system. Independent. Each microservices is independent and self-contained with its own business logic, data storage, and interfaces. This means that the changes or updates to one service do not affect the other, and services can be deployed and tested independently of each other. API driven. Microservices architecture is based on API, which allows the services to communicate with each other and with other systems. This enables services to be deployed in different programming languages and technologies, and to run on different platforms. Decentralized. The microservices architecture is decentralized approach to software development, which each service managed by separate team and operating independently. This allows for great agility and faster time to market, as changes and updates can be made more quickly and without affecting the entire system. Fifth, fifth point is resilient. Microservices architecture is designed to be resilient and fault tolerant, with each system designed to handle failure independently and gracefully. This means that if one service fails, it does not affect the entire system. Scalable. Microservices architecture is designed to be scalable, with each services capable scaling independent to meet demands. This allow optimal resource utilization and cost saving. DevOps oriented. Microservices architecture is typically used in conjunction with DevOps practice such as continuous integration and continuous delivery, which enables faster and more frequent updates and changes. Overall, microservices architecture is a modular, independent, API driven, decentralized, resilient, scalable, and DevOps oriented approach to software development that offers many advantages over traditional monolithic architecture. So these are the questions which we have presented. More interesting videos I will take. Please like and subscribe my channel. Thank you.